Okay, it looks like a machining project coming up here. My air compressor stopped compressing air. Took it apart here and found out why. On the piston we have the little gasket here, and that's what causes the compression. And on the front of the piston was a ring that held the gasket on. And the ring was welded on there, and the weld just broke completely off. I don't have any kind of welder, and I don't work with metal that kind of way, so I don't have this kind of tools, so I'm not going to do any kind of welding back on it, but rather I'm just going to go ahead and make a piston out of aluminum like I usually do for my engines, and I'm going to make it fit in here as a piston fit, because I cannot get, there's no warranty on this anymore. I have to get a new air compressor anyhow, so I'm just going to go ahead and make a new piston for it out of aluminum, like I said, and make it into a piston fit for here. Forget the gasket and just use it as a blow-by piston like I do for my engines, and just try to get as close as I can. Just try to get this working enough that I can get some air into there, and just see if it's going to work. If it works, it might be something I can improve on, maybe making a piston with a gasket or something, and maybe even put this gasket on there. We'll have to see. But this is going to be a machining project here to fix my air compressor. Stay tuned. Yeah. Okay, this is a little arbor I made so that whenever I make my piston I can screw that onto here, and then I can do my machining all the way down. There I can cut the piece down to the exact size I need it, roughly, to lengthwise, and I won't have to be wasting so much by putting this in the chuck jaws. I'd have to have more material here. But by cutting by making this arbor here, it allows me to save on material by cutting it to almost the exact size I need it for the length of it. Okay, here's the plans I came up with for making my own piston here. I'm going to have a compression ring made out of some plastic, and the piston itself is going to be made out of aluminum. And we'll see what we can do here. Okay, for the compression ring, I'm going to try some of this here plastic. It's a plastic shielding that you can buy for shield guards, chip guard shields. And I'm going to try to see how that would work for a compression ring. A small piece of aluminum here for the piston itself. I'll work on the piston first. Okay, your last 5/1000 spring cut here. We'll try the cylinder here now. I don't want a piston fit because I don't want any kind of friction in here causing this to heat up and expand in those C's, because I'm going to put a plastic compression ring on here, as I was saying. So I just want enough. That's good. There's enough play in there. Probably about 10/1000 of an inch play in there, which is good. And next, what I'll do is I'll make the compression ring now that will fit onto this here, and we'll get into that next part. Okay, so the next procedure now would be to go to my milling machine and work on the plastic piece. The compression ring will be the next thing. Okay, over here at my milling machine, I'm getting set up here now so I can make the slot for the compression ring. Okay, I have everything lined up on center now, so I think the first thing I want to do is drill in the center of this here for a lineup mark, for a reference mark. Okay, I'll move my y-axis 186 thousandths of an inch. X-axis 357 thou. Alrighty, that will set my bit up for an 1/8 inch bit for the reference hole that will start right there. I'll move on the I'll move on the x-axis now. 714 thou. Okay, finally on the y-axis 372 thou. Finally, return on the x-axis, that's 714 thou. Okay, that takes care of all 4 corners. change the thickness of this now. That's about 139 thou for the plastic part here. About 140 we'll call it, 140 thou. Set my z-axis for 140 thou depth of cut. Rounding on the corners here a little bit because of the end mill corners. Leave rounded corners. Alright, let's see how this fits now. Okay, it's going to fit good. Next thing now will be to drill to put the screws in. Okay, I took the time to get the center of my spindle on center of the workpiece here, so I'm now in the center. I'll take my compression ring blank here, put that on there, and then I'll start drilling now. What I'll do is I'll use my drill data here and to line up the holes for where they need to be drilled at, coming off center of the workpiece. Okay, now I'm drilling and tapping for a 256 screw. For the 256 screw, I need to countersink the head below the surface. It's about 165 thou. The head diameter. Okay, a number 19 drill bit will work for that. About 62 thousandths of an inch, about a 1/16 of an inch deep to countersink the head, counterbore the head. See how that works out. Alrighty, here's a 256 screw at the head, and that fits in there very nice. Next we have to move the x-axis again, 406 thousandths from screw to screw hole, keeping the y-axis completely locked yet. Okay, that's those two done. Now we're back on the y-axis again, and we're going to move the 682 thousandths from screw hole to screw hole. Okay, third screw, and then finally on the x-axis again, the 406 thousandths, and that would finish it up then. Okay, that's all 4 screws done. I'll take that out now and put that on my lathe. Okay, I tried to do this with the plastic, and I did that where I was tapping in the holes, but the holes are 256 threads, and the threads were just not strong enough to hold. So what I decided to do was to abandon that idea and to go with through holes, and to put the screws all the way through and put nuts on the other side. And so this is how far I got with this here. Now I'll put this in the lathe and we'll start machining this down now to the size that we need this. And that's coming up next. Alright, the first thing I'm going to do is cut these here screws down here a little bit, get them down to a smaller size. Okay, those screws are cut down now. Okay, now I can put it in the lathe. I'm sneaking up on the cut now. I got about maybe 5 to 10 thousandths more to go yet. I want to get this here as a piston fit. We're getting very, very close there now. Okay, try that. Ready for a piston fit now. Okay, next up now we'll be put this on my milling machine again and mill in that slot and the through hole for the pin, the connecting pin, and this will be ready to go then. I need to take the compression ring off one more time so I can mill the bottom side here. So what I need to do is just mark a reference here. Okay, I'm milling the groove in here now. Okay, we have the slot milled in here now, and let's see how it fits on the connecting rod here. Looks like it's going to fit nice. Okay, next thing now is to drill the cross hole going through here now, so we can hook that to the connecting rod. That's coming up next. Okay, I just drilled the cross hole here now, right here. So now we're going to go ahead and see how she fits on the piston here. Put the wrist pin in here. There we go. Okay. So we have enough taken out of inside here, so the piston fits, the connecting rod fits inside nicely. So the next thing to do now will be to put that there compression ring on, and we'll be ready to test it. Okay, it's time to assemble this now. I have my reference mark here for the compression ring to fit in that side there. Through hole bolts, 256. Now the 256 nuts, very small. Okay, in conclusion, it only went up to about 20 pounds psi because this is not a good piston fit. I gave it some slop. I wasn't sure if it was going to bind or not. Now the reason why I had to go with this here method here was because the first one I made a piston fit and it was all aluminum, and it just seized up after so long. It only went for maybe about 20 seconds and it seized up because the aluminum expanded. I decided to go with the plastic here, and this seemed to work pretty good. I got no seizing. I had no piston slap or anything. It actually built up 20 pounds psi, but again, because it's not a good piston fit, it doesn't have the pressure, the seal to give a good compression. But this gets me started on just practicing with different kind of materials until I come up with something that just may work. This is more or less just a practice project, just a proof of concept to see if I can try to fix my air compressor and how I would be able to do it. But it does work to a certain extent. I made it so that I can take this piece off and make a new compression ring and put it back on again and experiment that way there, and that's probably what I'm going to end up doing. And if I do come up with something that does work good, I'll post that in the next video in this series. But I think for now, this is the end of this series in this here project, and so I'm going to say thanks for watching. Bye.